Hello and welcome to the first Mik Plus One episode of 2021. On this podcast, I sit down with industry leaders to discuss the project-to-product movement. I'm Nick Kirsten, founder and CEO of Tasktop and best-selling author of Project to Product, How to Survive and Thrive in the Age of Digital Disruption with the Flow Framework. Today, I'm thrilled to welcome back Adrian Cockcroft, VP of Cloud Architecture Strategy at Amazon Web Services. Adrian joined me on the podcast last year in August, and since that time, I've had numerous people tell me they wish that podcast kept going because they found Adrian's teachings so incredibly valuable. A decade ago, Adrian was telling the world about microservices, and those who listened to him gained a fundamental advantage over the competition. In this podcast, Adrian covers key trends I think will have as fundamental an impact on us a decade from now. He also summarized some key technologies that we need to start understanding and start implementing today, ranging from serverless to new approaches to continuous resilience, all the way to more forward-looking things such as understanding and reducing the carbon footprint of our cloud workloads. I hope that you find this conversation as fascinating as I did. So with that, let's get started. Adrian, welcome back to the podcast. I've been trying not to have repeat visitors, but I got a lot of emails after the last podcast from one of my closest colleagues who told me that was the best podcast, pointing at you, of course, nothing I said, that he'd ever heard. So personally, for me, it actually changed a lot in terms of how I've been engaging and talking to people. So I can't even tell you the number of times I've said and reflected on the theory of constraints for your observe-orient decide-act loop, your OODA loop. That's now become a part of almost every presentation I give. That term that you shared with us, the cloud for CEOs. You talked about some of this in the last podcast as well. I recently counted. I've sent out that white paper of yours about 40 times for
cool.
decision makers. Well, yeah, I think it nailed some of the key points, right? Everyone's dealing with all of this complexity in terms of how to measure their move to cloud, the obsession on measuring just cost. You provide everyone a very clear way of measuring value. For me, in terms of the Flow framework, that's all actually measurable through flow time, how quickly we can get time to value, time to market. And I think, again, so that clarity of thinking has been super impactful with everyone I shared it with. Thank you again for the introduction to David Anderson, who then joined on the podcast and told us about how he's actually accelerating his time to market at Liberty Mutual IT through serverless. And on this one, I really would like to actually hit on some of these key topics and build out what you presented in this incredible talk at reInvent. So I think You've presented us with key trends for the industry 10 years ago, which many people are now adopting today. I think you've now got in that talk such a great range of where we've come on things like serverless and from microservices to what's next with just complete changes in hardware architectures. They'll transform application architectures. But why don't we start with some, any reflections you have on the last time we chatted, and then yeah, I'm eager to get into you telling us about some of your predictions for application architecture in 2021.
Yeah, well, thanks. It was a really fun podcast, and it's great. We're sort of very aligned. And as I said then, I used to go and talk to customers and say, well, there's this book you should read. And it says, oh, yeah, we had Mik in here a week or two ago. Okay, well, I'm going to start my conversation in a completely different place. So exactly how are you doing this rather than you should be like all the paths and the steps. And there's so many customers that have been trying to just like lead down the path to get close to it. And every now and again, I run into somebody like Dave Anderson or some of the other customers that are right at that leading edge. I don't have to explain what a Wardley map is. I don't have to explain the project to product and all this stuff. And it's just I really like engaging deeply with those customers. Then I start learning stuff and go, okay, so how are you doing that? How do you convince people to do these things? And we can then share that across the industry and start saying, this is possible. We have existence proofs. Because that was always the thing with Netflix. It was an existence proof. You can say, oh, that's impossible. No, we really do that, right? And then I have all these other more recent customers I've spoken to that really are doing these things. So you can't say it's impossible, and you can see the value from it. But it's maybe incredibly frustrating because you just can't get there from here. So at least you can see that there's a thing there, right? So that's kind of the fun part and the pain in the neck part.
Yeah, I think that's exactly it. And that's, for me, that what David Anderson said that you led up to is exactly that. It's an existence proof that this isn't as hard as you think. And then just the only interesting part is it exists. They got there fairly quickly. They trailblazed much more than others have, let's say in the case of Lambda and serverless, but it's really how we get from here to there. So I think the really interesting thing is, again, you've been feeding the industry these existence proofs, starting with things like microservices. And yeah, I would love for you to take us through sort of the next set of existence proofs that you've come across and how we get there. Now, you will probably have to explain some of those. So John Willis on this podcast did talk about Wardley maps. You may have to go into a little bit more explanation. But the fact that you're using these tools, these architectures, these technologies, and these services today, and in helping customers move and innovate faster, I think is key. And for everyone listening, this is not things to consider for 2022. This, I think, everything I heard from your talk is things that I know we're applying with organizations I work with within my organization for 2021. So why don't you start us off, I guess, on the 10 years ago, what's happened with microservices and how on earth it is that an enterprise IT organization the size of Liberty could move to serverless so quickly.
Yeah, I actually wanted to start one step before that, because 1 year ago at reInvent, I did this hour-long talk on speeding up innovation, which was then also published as this booklet that you mentioned, the Cloud for CEOs, which is sort of the distilled version of that. And this comes back to this thing. And it's like, well, why can't you get there? And the way I structured this talk was there are like 4 things getting in your way in 3 stages you go through. The 4 things were kind of the culture, the way you were organized, the way that you dealt with the sort of financial risk and board level things like that. All those things got in the way. And then the stages you go through was the first one was learning to do something small quickly, and then learning to do sort of large scale cloud native net new projects that are at scale, sort of that Netflix architecture kind of thing. And then finally going through the data center migration, digging out all the old legacy stuff and figuring out how to modernize and migrate that. And that kind of gave me a framework for talking about all the different ways. And sort of the big message out of that was I saw time to value, or your flow as the key metric. If your time to value is really short, then you are able to innovate quickly. And that's sort of it forces everything else to be good if that one metric is good. And that was kind of the discussion we had last time. So going into this year's sort of reInvent thing, I was like, well, I don't want to do that talk again.
For the record, I do think people need to listen to that talk. I've listened to it. It's, again, the clarity it provides organizations. So again, we're only focused on the cost aspect of everything, and they're just doing the wrong things around lifting and shifting. Yeah. And again, you provide this very clear guide, focus on time to value. You'll both reduce cost. You'll innovate much faster. You'll learn more quickly. But so it's an hour long. It's like an hour long. It was just I'd given that talk in various versions of it for about a year and a half at that point. I was like, okay, this is the last time I'm doing this. It's like I'm just going to get it. I'm going to go through all of it. We're going to do the hour long version. I've done it so many times. I know the story. So it was a very well rehearsed pitch, and I had a nice big audience, and I was on the big stage in one of the theaters there, and it was just like, okay, put a bow on it, right? Done with that. But then coming into 2021, I was thinking, well, what do I want to do? And one of the things I sort of hacking the system for reInvent is they don't normally list the authors, but I put my name in the title of the talk. This is very much can I get away with that? Okay, I got away with it. So it was Adrian Cockcroft's Topics and Trends for 2021 was the title of my talk, and that meant you could find it. And there was a whole lot of issues with trying to find talks before the full catalog went out. So the pre-catalog was a bit limited, but you could find my talk. So that was cool. And then somehow, we all had half an hour. So in 30 minutes, I tried to get through 5 different topics. And that was just like, can I jam them in there? So I basically was talking about serverless, the sort of high availability chaos engineering space. I call it failing over without falling over. I've done 2 large talks that are like 40 minutes each, both on those topics individually. So I was just like doing a very distilled, like, well, this is the distilled version of that topic in 10 minutes kind of thing. And then I talked about Wardley maps briefly as a trend that's not really here yet, but I'm predicting it's going to be a thing. Because for the whole serverless and microservices space, I kind of did one of those Google Trend maps showing up the last decade or so and showing that, I started talking about this in 2013 and it's pervasive now.
And chaos engineering, again, started talking about that in 2010, and it's pervasive now. And Wardley maps, it's not really pervasive yet, but I'm sort of predicting, hey, I was right twice, maybe I can be right on that one too. Well, there's like a future prediction. I think it's going to be big. But right now, what I'm seeing is that those leading edge customers are using Wardley maps. Liberty Mutual are, some of the other customers are, and they are getting a lot of a lot of clarity and value from the technique. So we can talk a bit about what that is. And then I have this long-term project. Not really a project. I've been thinking about really large memory systems for a long time and talking about it. It's not really related to my work at AWS at all, but I think it's a trend that's gradually happening. And then finally, the thing that I'm trying to focus on myself in 2021 is around sustainability. So I talked about some work I'm doing there with a Linux Foundation project. So that was kind of the 5 topics.
Yeah, so let's dig into some of these. So I think I may as well just go in order. So serverless, one thing that you mentioned that actually, in terms of the time being now for serverless and the fact that it's not only proven out in tech companies as the fastest way to deliver these applications, but the fact that Andy Jassy said half of new services at AWS are now being built on top of Lambda. Is that the case?
Yeah, he said that during reInvent. We've been repeating that quote. It's just say this isn't a niche thing. And you heard from Dave Anderson, serverless first is kind of their philosophy, and that's kind of the phrase that the way I think about it. I've done that talk quite a few times. You can go find videos of me giving the serverless first pitch. It's basically, if you have some problem to solve, try to use serverless to solve it first, because you'll find out in a couple of days whether you can do it or not. And then if you need to maybe do the several week version or whatever, if it was going to be a many month long project, take a week to build a prototype. And it's kind of like, when I first encountered Ruby on Rails, I was working at eBay Research Labs with Mike and the two of us, we went into a meeting and somebody was saying, we need to prototype a thing. And I was chatting to Mike, say, well, how quickly could we build that prototype? And I sketched out at a spreadsheet what I wanted it to look like, and he built the Ruby on Rails version. And we went to the meeting a week later with a working prototype. And we said, where did this come from? Well, we just built it in Ruby on Rails. All of this stuff is default. It's all common. You can build an actual, reasonably reliable working application in an afternoon. It's basically what we did. And this was sort of mind-blowing at the time. And it showed the sort of value of using frameworks that are a very high level. And so what I see is, in a similar way, sort of using Lambda, you're putting together all these building blocks that are already scaled, they're already highly functional. And if you can build the Lego version of your app, you can build it in a few hours. If you have to build the full custom version, it'll take forever. So that's kind of that Lego analogy has been something I've been using for a while to try and explain the difference to people. So that's kind of the core of it. And the reasons why you can't do it, we just keep playing whack-a-mole with them. You can't do this thing. No, we fix that. Well, you can't do this. No, we fix that. This is too slow. No, we fix that. Right. So every time somebody comes up with a reason why they don't want to use serverless, we go and add another solution for that objection. So the long version of the talk is just working through all these objections and showing how they don't actually apply anymore. So that's kind of the long story.
Yeah, and we'll link all of these materials for your other talks. So those are available for those who want to follow up on this. But Adrian, how would you suggest, again, to the CTOs out there listening and to others, I think the key thing is you need to know how this works, and fundamentally, we can touch on this in the Wardley maps as well. This will allow you to focus on the value portion of your application, not on reinventing even more wheels as so many are doing. So how what's your guidance just for the next greenfield applications that you've got? How do you see people getting started to sort of follow that path that we saw from David Anderson, which is trying it out in the small quickly? Because I think the fascinating thing to me about that was just the path from trying it out on an MVP, on some internal prototype, in their case, was actually a pretty significant application, and how quickly they went from concept to a proof point for the business, that their ability to bring something to market was now 10 times faster than with any of the other stacks that they were using. So what's your guidance there?
I would actually start with step functions for most things. Step functions it gives you a stateful workflow engine, which is sort of has Lambda embedded around it. So it's actually not just serverless first. I'd say step functions first. So take a look at that and understand what you can do with that. And there is so much functionality there that gives you the framework for all these business processes that people are generally trying to build. So that's where I'd start. The other place that's interesting to start is call center applications. And if you see the Connect product that AWS built, it's basically, it's the sort of Alexa backend with Lambda sitting behind it and a totally dynamic call center on demand, right? And there's a lot of it turns out to be one of the easiest things to adopt, because call centers are very large. The traditional vendors are very large, rigid, difficult to innovate around. And this is where your customers are talking to you. You want to innovate directly in that customer contact place. So it's been an interesting on-ramp for a lot of customers into serverless. Just because what you end up building out of the back of Connect is serverless bridges to everything else you do, and then you just learn to do it. So I'd say those are the interesting places, but have a hack day. If people don't know how to do it, give people permission to play, right? And I think hack days are great for that. Give people an unconstrained hack day. You can play with any AWS services you want. We'll give you a burner account. We'll bring in some AWS solutions architects to kind of do some hand-holding if you get stuck on something, and just have a day where anybody can build anything and play. And they will, it's a bit like the Deep Racer. If you want to play in AI, there's this Deep Racer League where people are going and learning how to do various kinds of reinforcement learning and stuff like that. But just in the serverless space, it's liberating and it's fun. Just pick a quiet week and have people just go build something. And that way you learn, and then they go back to their day jobs and go, hey, I've got a bunch of tools at my disposal. And it really doesn't take more than a day of immersion to learn serverless. Like, we've seen so many people go into a hack day not knowing it at all and have built ridiculously complex applications like in a day. So it's that was kind of that's part of the talk. I mean, there's this light bulb moment I had watching people at hackathons using serverless.
Well, yeah, and then just how much less time goes into configuration and setup and wiring on those hack days. It's an amazing technology for hack days, right? We've seen the not-for-profit hackathons that have been hosted, which again, it's just amazing how quickly people can get results that are interesting.
Yeah. And it's a bit of a dig, but there's a grain of truth to these digs, which I say that in less time, you could finish building your app in less time than you'd spend trying to decide how to configure Kubernetes.
Right.
Right. You're still having meetings about exactly what version and how to configure Kubernetes, whereas the serverless team has finished building the app and is off building something else, right? So it's a bit of a flippant comment, but there's definitely a grain of truth to that, right? You can certainly build a very productive environment around Kubernetes, but there is a lot more configuration, a lot more stuff to learn, and a higher bar for getting into it, whereas serverless is like, you're done, you built the thing.
Yeah. And just on that note, the call center thing is really interesting, because the number over the past month or two, the number of large financial services organizations whose business has transformed enough that the call center queues have exploded, because people are not going to physical locations, everything's more online and I guess over the phone, which I didn't realize. It just seems like an amazing place to quickly demonstrate value to the business, given how much leverage you've got there in terms of actually applying some machine learning to proper routing of calls and other responders and so on. So yeah, I think that's some great low-hanging fruit.
I've seen one large bank, one of the large global banks, at one point, I'd say their AWS build was completely dominated by Connect. It was the first thing they got into production. It was their on-ramp to cloud at all, right? Yeah. And it was a huge successful rollout for them. And then they went, okay, we learned a lot there. Now, what's all this other stuff you've got, right? So It's just almost as a standalone solution. It's an incredibly powerful way of thinking about it, because it's just like Randall Hunt used to demo creating a call center in 5 minutes. You can probably go find a video of him doing that. He'd make a call center so his mum could call and find out where he was with his demo. Right.
And now, so in terms of, let's say that now works, scaling that in terms of, you're now dealing with these kind of massive data sets if you are in a large bank. How has Lambda and the AWS adapted to what you're describing, which is just much larger scale?
I'd say the very early versions of Lambda were more experimental as an implementation, and at some point we realized how much critical work was being done on Lambda. And there was a period several years ago where we re-implemented all of Lambda from top to bottom as a much more resilient system. And that was, sort of reaction to the kind of applications people were building. So the overall resilience of Lambda, the security model, it now runs as every Lambda function is in its own Firecracker micro VM. That's giving us a lot of capabilities and from performance and security, isolation, all kinds of things. It used to be that there was an instance and all of your Lambda functions would run effectively as containers within that instance in some sense. And so they sort of compete with each other. But now you've got a separate virtual machine for every Lambda function. It gives us better isolation. So there's just all these ways that we've been hardening it over the years. And the event bridge and pre-allocating functions. And you really can, if you need a Lambda concurrency of, say, 100,000, call us, we can do that. That's insane. Like I need 100,000 machines, 100,000 CPU cores.
Wow.
Because I have a lot of people turning up to click on something at once or whatever. It's like, we can do that.
Wow.
Yeah, it's not the default. The default's 3,000, I think. But, we can increase the default. That's just ignore. You can do the incredible burst workloads and flash sales and things like that. So it's that at very low cost. So that's the fun part with serverless. The other thing you were sort of alluding to then is it gets into the next subject, which is this resilience and failing over without falling over. Another talk I've given a few times where I really start with, you can look at all kinds of places you can start with resilience, but rather than starting with trying to explain what chaos engineering is, I start by saying, so have you got a backup data center? And everyone says, yeah, of course we do. And then I say, well, how often do you fail over to it? They start looking a bit uncomfortable. And I say, well, how often do you actually kill your entire data center and just flip to the other one? And they go like, never.
Yeah.
Or like, only because it happened, right? Something broke. And then we found it didn't work, right? So you've got this, it's like buying an insurance policy that never pays out, right? You spent all that money on this insurance policy, which is sort of mandated, but you never have a claim against it because you can't actually use the failover because it doesn't really work. And it just seems like a huge waste, and everyone agrees that's a waste. So and it's all bespoke, it's done custom every way. So the idea of the talk is that we should be able to fail over without falling over. And to do that, we use common patterns that are highly symmetric, highly pattern-based. Cloud gives you the standardization. These Grace Cloud services give you building blocks that are very, very hardened. You should be able to build something which is absolutely rock solid. At any point, if anything goes wrong, it'll automatically flip from running on 3 zones to 2 with no intervention, with no complaint, but like a single alert saying, by the way, a zone went down. That's a bit hopeful, but it's plausible, right? And you should be able to, on multi-region failover, it's usually more manually triggered for various reasons, but you should be able to say, yeah, I need to switch I need to switch out of the region, push a button and have it just happen. And be a well-tested thing that is going to work, right? And we have some customers that are doing that. Netflix is one of them, and that was the architecture I built years ago with them. But more and more customers are getting to that point where they either are doing that or they want to do that. And then the thing is, how do you test that? And that's where you end up with chaos engineering and the new announcement of the failure injection simulator and fault injection simulator. So you can basically put faults into your environment and show that your system can deal with those faults. And the new product, the new service we've announced gets deeper into the system than you can from outside. And that's really why we had to build it. We're getting into some APIs and layers of the control planes that we wouldn't expose to customer APIs normally.
So you've now exposed more private APIs to drive failure injection, you're saying?
We haven't exposed the APIs to be public. We've exposed the capability through the service, the failure injection service.
Okay. Yeah, got it. So and I think the key point that you made is, we're moving from disaster recovery, which, insurance policy never paid off. And Yeah, like you, the only cases I know of sort of, Fortune 100 usage of that insurance policy is when there was, it was an actual, massive fire on the West Coast or something of that sort. And then things never worked as planned anyway. So from disaster recovery to chaos engineering now to continuous resilience. So if you could can you just describe how you think about continuous resilience from the application architecture level? But I think the really interesting thing that you started talking about is actually this human factors and kind of safety community level being a part of this, right? Where the wrong action is taken, and all of a sudden you've actually flooded the system with traffic that shouldn't have been there. So this is a more holistic view of chaos engineering than I've seen. So if you could just describe.
Yeah. So some chaos engineering, you have an application, say a microservice, you inject some faults into it. It's got like 5 dependencies. Whatever dependency goes offline or becomes slow or starts giving you errors, and you're hardening your microservice. So that's a relatively well understood model. It's kind of nicely contained. And you should be doing that for every microservice you've got, right? This larger scale thing is like a zone level failure. Like what happens if every resource in a zone goes offline, or if a particular service in a zone stops working or something like that? How do you respond? And like you said, I've got into the safety community a little bit more. There's a few key people here. Sidney Dacker is probably the main one, and I like his Drift into Failure book is something I've been recommending for forever. I did an entire talk based on chapter 2 of that book, which is about a plane crash, and I wrote the talk while I was on a plane, and it was a little uncomfortable for people when I gave it. That was a go-to Chicago talk from 2017 or so. I could dig that out for the show notes, find the actual link for it.
We'll add the link.
And there's a guy called Todd Conklin who has a podcast called the PreAccident Podcast, and he's one of the leading lights in this space. And I actually went on his podcast and chatted to him about chaos engineering. And he was one of he ran safety for the Los Alamos labs or Sandia labs or something, like testing nuclear bombs. Don't do that. Don't get that wrong. You need some good safety around this stuff. And he's like a really deep thinker in this space, and just a really entertaining podcast, worth listening if you're into this. And John Osborne's been on it, a bunch of people. So every now and again, he dips into sort of the DevOps and software safety community, but mostly it's about industrial safety. I've got an aluminum smelting plant, or or a construction site, and I'm trying not to kill the workers, right? That kind of thing. And it's really good to have that perspective, because they've been learning things over the years, and we look at it in this blameless postmortems. All this kind of stuff comes from that space, right? And John Osborne in particular is deeply into this, and lots of good research that he's done. I have a slightly different take on it because I'm coming at it to try and solve a slightly different problem from John, but it's all very aligned in what we're doing. And I think the key thing here is, if you look at a control system, I tried to draw a control diagram which has, and this goes to MIT's Nancy Levison's book, Engineering a Safer World. She's an MIT professor, or I think she's a professor there. She runs a big team. And there's this technique where you lay out a control system, and you're treating your reliability as a control system problem, and you're using all of the decades of research into control theory to do a much better job than sort of the making it up as you go along approach a lot of software engineers have. There is a body of work there which I'm trying to expose to software engineers. And so you have your data plane, which is the business service that's doing the work. Then you have a control plane, which is all the code you wrote, which is managing that, which is doing like fault analysis, it's doing performance monitoring, it's maybe doing fraud analysis and looking for bad actors, or filtering at the front end. All of that is control plane activity. It's not the core business logic. And that control plane can only manage the data plane if the data plane is behaving in a predictable way. So it's got a model of the thing it's controlling, which is implicit, which is, if you see this metric, do this. It's that alert, like if then else kind of thing, if this then that kind of idea that you have, or your autoscaler saying if your CPU gets busy, add some more instances, right? And of course, if you're out of memory, your CPU won't get busy, your machine will be sitting there idle, and it won't add instances. So your model was wrong, right? So that's a class of failure, is model failure, looking at the wrong metric. And then sitting above that is the human layer, which is another control plane layer, which is looking at this whole system. And the human has a model of the controlled system and the control plane And every operator will have a slightly different model because they all know different things. And then you get all these problems where operators have different models and there's conflicts and they're looking at the wrong data and they're using runbooks that are out of date and everything goes wrong. So that's kind of there's a fairly detailed discussion of the typical hazards. And there's basically a hazard checklist for sensor data, for control actions, and for model problems. And what I'm really trying to get to in this really short summary was like distilled version was like, go look at these checklists, think about your own, like try and draw the control model for your system and just run through these checklists. And this is like looking at the wires, not the boxes. You effectively have a box and wire diagram. Instead of saying what could go wrong with this box, say what could go wrong with the wires connecting the boxes, which is the information flows and the control flows. And then I don't care, the box is a black box now. If it starts misbehaving, some of the outputs are going to be different, right? And I should have enough outputs to be able to tell that it's misbehaving. But I don't need to really get into what's happening inside that black box. It's a sort of good way of thinking about the abstractions. Kind of a little brain dump on that technique. And I've got a few customers I'm working with that and some solutions architects where we're trying to actually come up. The next step is to actually have a real control diagram for a real application, and I've not quite got there yet.
Yeah, but Adrian, I think this is huge from my point of view. I'll sort of relate it to an experience I had in terms of, because in the end, this is just managing safety and failure modes in complex systems, right? And I'll never forget this trip I made to the software and hardware lab of an electric car manufacturer, and then I was talking with the inverter team, and they said, so we have hundreds of engineers working on the software for the inverter. I said, what? Like, what? How do you have hundreds of developers working on this embedded software for an inverter? And I asked them to show me because that's, I thought it was really neat, but I had no idea why. And if we really think of the inverter, which is just putting current onto an electric drive motor, they said, and I just always thought of it as that lowest plane, like your data plane, right? That's actually pretty straightforward. The ways it's the control plane where all the software is running.
Yeah.
Because in that inverter, you can have over 30 years, every single component malfunction in different ways. And as they put it to me, no matter what the human controller does, it can never apply a bit of gas and then end up going through the car in front of them, right?
Yeah.
You can never have that kind of failure, regardless of what misreadings you're getting from the hundreds of sensors on these things and so on. So I think there's something so profound about this observability and control, this SPTA model that you're now applying for cloud scale systems.
Yeah. When you're in industrial control systems, and that's a key one, you have to get it done right, and you have to be able to deal with every wire going into that thing could have a bad connector on it.
Yeah,
exactly.
So
what are you going to do? What's it supposed to do? It's got to fail safe. I have like a slightly the first times I ran into this was before I joined. I was a software engineer working in embedded systems, and a friend of mine was an expert witness at a trial because somebody had built a circuit for controlling a baby incubator for premature babies, and the circuit failed, and it failed on. And it overheated the baby and killed the baby. Wow. And it's like, this is the kind of thing that sticks in your mind. Oh yeah, don't do that, right? Yeah. Let's make sure that all the failures are going to fail safe. And you have to think about everything that could go wrong, anything life critical, anything that's controlling machinery. And then when we're looking at large scale systems, sort of cloud-based systems, you can only automate so much. There's always going to be humans in the loop. There's this term that Sidney Dekker has called synoptic illegibility, which is one of those words. What is that again? So a synopsis is a summary of how something works, right? Can you write a synopsis for this thing? If you cannot write a synopsis for how to operate a thing, then it is illegible, right? So there are systems that you can write in theory how it works, but how it actually works in practice is a human every now and again will get in there and tweak it.
Yeah.
That's because most processes that are reasonably complex have synoptic illegibility, and there has to be a human watching over it, and you cannot automate everything that's in there. Because you're not going to capture. You do that work to rule thing, right? Work to rule systems don't work well, right? If you follow the actually what it says in the run book, you will end up running off the end of the runbook and into a no man's land, right?
Yeah, and then some of this just seems so pragmatic. Again, I encourage everyone to dig into this part of your talk, but the fact that the FUD of alerts from a human point of view is like a fail always on. There's no information in it for the human, so they take an action and then further floods the system with requests. So fascinating. Yeah. And then, Adrian, I want to ask this. I think the really interesting thing I'm noticing, and I think in how you're applying these concepts, is with this kind of continuous DevOps mindset, right? Because I think, like you said with Lambda, right? Like the compute scaling's there, the storage, all of this is there. But I certainly have heard organizations say that, well, how, we've set up our build pipelines. I think it's generally a good practice for them to have one set of well-governed DevOps and delivery pipelines. You've now touched on how organizations should think about pipelines that are, at least at the outset, going to have, let's say some microservices, some other legacy applications, and then some Lambda. How do you think really about applying these? Because you're mentioning continuous resilience. You're mentioning applying Lambda to existing build pipelines and new services AWS has for that. Again, I think from that DevOps and delivery point of view, what have you learned over the course of the last year that can help people apply this to their pipeline?
I think continuous delivery, from talking to Jez Humble over the years, like if it hurts, do it more often until you figure out how to make it stop hurting. That was one of those principles, like why people weren't doing continuous delivery and hundreds of releases or thousands of releases a day or whatever. And so if you look at continuous delivery of code, then you look at, so what else needs to be continuous? And security needs to be continuous. You need continuously provable state of audit state, right? So you want continuous compliance, not point in time, somebody turns up with a clipboard and asks you awkward questions, compliance to audits. You want to be able to prove that the system has always been compliant because you have an audit trail in a tamper-proof log. So that's continuous compliance. And then from availability point of view, instead of having the sort of annual failover tests, which everybody spends a month preparing for, it's kind of like the annual audit, right? It's something which you should be continuously ready to do and continuously prove that you can fail over and that whatever goes wrong, the mitigation plans that you've got are known to work, right? And that's a state of being which you get to. It's the same kind of transition. You go from sort of annual releases of software to continuous delivery. All of these things, the security, the availability, and the software and the feature delivery all become continuous, and you're going to get this economy of scale. There is no economy of scale in things. Doing smaller chunks are better. The more you bundle together, the harder it is to do. So you want to have lots and lots of tiny tests and lots of tiny proofs in the system that show you that everything is working right. So that's kind of
and are you saying go as far as injecting failures into production as part of your delivery pipeline?
Yeah. So, your delivery pipeline is really puts an artifact into production, right? So then when that artifact appears, I'm just going back to the model we had, kind of just thinking the model we had at Netflix. Like when a new version of a service appears in a test account, that causes a trigger, which causes the security system to go and run a penetration test on it. It's just automatic. Every new service will get pen tested. It's just a default thing, right? And if you left a bunch of ports open you shouldn't have, you'll find out immediately, whatever. And the same thing for performance. Every new service goes through a ramp test where you basically start it up, look at the error rate, look at the response time, and it's a microservice. It does one thing. You just ask it to do that thing at a higher and higher rate until it keels over. And one instance of this can do 800 things a second or whatever it happens to be. And that data is then collected, and the error rate was at a reasonable level. Okay, you passed your canary test you passed your ramp test, or whatever you want to call it, your stress test. It's now a candidate for production. So that's just a step. When it goes into production, you run a canary test in production, which is basically chaos testing. You run a bunch of them side by side, and you maybe inject some faults into it, but you're looking for its ability to behave at least as well as the previous version of the code. You run some side-by-side tests, and maybe you actually run some chaos tests against both of them to show that it's responding at least as well to the chaos attacks as well as the regular use cases. So it just becomes part of that pipeline for building hardened code that's going to work in production.
Yeah, I think that's such a fascinating, powerful thing, right? Is that the pipeline now touches live production to drive resiliency, right? And I think a lot of organizations have gone to the point where their pipeline is doing the penetration testing, it's doing scanning of various sorts, whether it's for licenses or other issues, and now the pipelines actually extends exactly that same way to production and chaos engineering. So,
yeah, the other thing, I mean, just going back to announcements at reInvent, we announced that you can actually package a Lambda deliverable as a container now, so you can use the same build pipeline for building containers and also for packaging Lambda functions. I mean, you're packaging it differently because Lambda functions would have different code in it, but you can use the same build pipeline to deliver into both containers and serverless as, so for your long-running, highly scaled, very specific instance type services where you're using containers, you can use the same pipeline for that as for your Lambda functions where you have your rapidly iterating business logic.
Yeah,
that was just yet another one of those bits of friction that we took away.
Yeah, and I think this is the interesting thing is what we're seeing in terms of how much is provided now as a service from these pipeline services to failure injection services, and I think maybe this is probably a good bridge into the Wardley mapping, because the pace of change, and I certainly know that at Tasktop we're always looking at this. Is like, why did we build that thing on top of EKS when it's on? It looks like it's already there already, or there's some other open source project that's handling that, or another service that's been launched by AWS. So I think one of the sort of interesting things for technologists and large organizations is to actually map out where they put their organizational efforts, right? And of course, like to think of everything as a product. Your own platforms and data pipelines and APIs are products as well. But the pace at which you and AWS and others are actually delivering these new services, to me, was a pretty profound thing. That there's now this failure injection service. I thought I thought that was amazing. So these Wardley maps, I think, for just to connect the rapidly evolving technology landscape, what's core, what's context. This has been a common theme on the podcast. Where do you invest in order to drive the most innovation? Where do you not invest, right? Where do you actually rely on services in the shift to cloud? Can you just tell us how you think about this strategic decision-making tool of Wardley maps? Because I think it is, I agree with you. It's such a powerful tool to help organizations navigate a very rapidly changing technology landscape.
I think Wardley mapping, you can use it for so many different things that you can kind of get lost to start with. So I like to focus on one really solid use case we see all the time in the cloud, which is a technology stack and how it is evolving over time, where the 4 stages are: I wrote some custom code that does a thing. Like if I'm writing a file to disk in my own custom format, and I'm reading it back from disk in that format, right? That's custom code. The next phase would be, I could use a database for that. So I will buy a commercial off-the-shelf database, and I will use that to store my data. So I'm no longer writing to the disk. I'm using a commercial product. And I'm going, there's actually a pretty good open source version of that commercial product. So I'm going to use that. I'm just going to use MySQL because I can use it for free. And then the final step is it's a pain in the neck running MySQL servers. Why don't I just use RDS and somebody else runs it for me as a service? So now there's a service there which will just store my data for me, and I read it back, and I don't have to think about file systems. I have to think about buying a database and about running a database. It's just a service. Somebody else is doing it all for me. So those are the 4 steps that are characteristic of technology layers, right? And if you map out your value chain from the most customer-facing piece of your technology stack, which is probably your mobile phone app or a web page or something, all the technologies you're using to build it, and then you layer them in their dependency order, and at the back of them, the dependency goes, well, this code is running on a machine, and the machine's running in a data center or in a cloud, and that cloud depends on buildings and data and power and all those things. So you can go all the way down the stack to the utilities underneath. So the Wardley map I'm describing basically is a value chain top to bottom, and it's the evolution left to right. And things in the value chain migrate from left to right over time. So that example I gave, custom written code evolves to a database, evolves to an open source database, evolves to an as a service database, right? And then you stop caring about that. It becomes part of your lower level infrastructure. You build something new on top that you'd only have time to build if you didn't have to worry about the database. It frees up your time to build the higher level function. So this is the other part of a Wardley map is to push things off your need to worry about it space so that you can do more innovation. You're always like, what is the new thing at the top of the value chain that's on the top left side that's new and innovative? What's the genesis thing? What is the thing that's never been built before? And that's where you should be spending all of your attention. And all the stuff underneath, you want to push it as far to the right as possible. So the way I use this with a customer is I say, okay, what is your current technology stack? And we draw the value chain, and we draw it out as it is on a whiteboard or in a shared space or something. And the customer looks at it, and everyone in the room looks at it and says, yep, that looks like what we run. Like, oh, what about this thing? Okay, well, I forgot that. Where does this fit? So people, until they've run out of things, and they've run out of arguing about what order the dependencies are in. And then usually by this point, there's a shared understanding in the room of what their actual architecture is. And most people don't understand what and that is your technology stack, right? Then you can say, well, what do you want to do with it? Well, here's an existing, what programs have you currently got in place? Well, we're migrating this to this. Okay. Almost all of the technology innovation projects you have will be moving to the right. You'll be taking out some proprietary, you're replacing Oracle with Postgres, for example. Okay, you're moving a off-the-shelf, highly cost enterprise licensing thing to something you can use for low-cost licensing or as a service licensing, that kind of migration. People are working through all of those. So you start to draw what's already in plan, and people can then see, okay, that's what we're working on. Again, people in the room will discover that things they didn't know that their colleagues were doing. And then you can say, what else do we need to do? And where do you want to end up? And that's kind of becomes then a template for communicating about what is your cloud migration really about? Yeah. And once you've done that, you've drawn all these Wardley maps, and most people that haven't seen a Wardley map before go like, well, that was so clear. What the hell is going on? And you're not getting into the weeds of exactly what your architecture is. It's just that, Kubernetes depends on etc.d. That's it. It does. So are you running both of those yourself? Or are you running it on EKS? Are you running a custom version? What are you doing here? Right? And every now and again, you'll pull something that's at the right-hand side of the evolution and pull it over to the left. And because they say, electricity is such a fungible utility. And then you look at, well, a Tesla supercharger is not a off-the-shelf thing, right? You do not plug a Tesla at home into a wall socket. They had to invent new ways to deliver ridiculous amounts of energy safely. And so there was innovation in that electricity provisioning layer when car charging came along as a new requirement. So you suddenly see innovation in some area that was deeply in this is just boring, right? You know how to put in a 40 amp socket in the wall, but all the technology to deliver that. So that's kind of it's not that innovation isn't happening on the right side because you're innovating and building services. It's just that from a customer's dependency stack, you're moving to the right. What I did in the talk was I picked the Kubernetes ecosystem and looked at the CNCF landscape, which has millions of icons for projects that most of you haven't heard of. And I picked out the ones I thought I'd heard of that formed a stack for Kubernetes. What are the dependencies? What are the projects that make up a Kubernetes stack? And then showed how they were gradually migrating to as a service with EKS. And then during reInvent, we announced Prometheus and Grafana as a service, and there's a distro for collecting data. I've forgotten what it's called right now, but the thing that feeds data into Prometheus, whatever. And all of those, I drew, okay, those things now move into the as a service. Yeah, you can run your own Prometheus, but now you can get it for free. Or not, you can get it without having to build it in. It's just part of the entire bundle. And Grafana is an interesting story because the company was formed, I think the first time they ever stood up and said they existed pretty much was at a Monitorama conference where I was sitting in the audience, and I'd start texting my venture capital friends saying, hey, look at this one. I think we should invest in this. Like everyone in the audience is running this. And it was like, this is like a huge, go invest in this. And we didn't manage to get any money into it because they didn't need money, but that was one of those ones where, okay. And I went and chatted to them and got to know the founding team pretty well. And when they started working with AWS, I was able to smooth that transition. I was working in the open source team, and they were talking to Grafana, and sort of I was able to use the fact I knew the CEO and the people at Grafana to sort of build trust into what has turned into a really powerful relationship where Grafana are now licensing their code and their development resources to AWS. We're embedding it in tools at AWS, and AWS has the commercial version of Grafana available as a service. So it's kind of a win-win. There's a really long-term contract behind that, and I was very happy to see that outcome. And it's kind of a template for how to do it right, how to really leverage the cloud from an open source vendor perspective. So super happy to see that announcement, building on several years of working with them.
Yeah, I mean, I have to say this, when I looked at this diagram and itself that you created had me for the first time understand at a higher level the dependencies of all those logos of all the projects in CNCF. And I think that speaks to how important this is, right? Because so often these architecture diagrams of dependencies, all our legacy systems, all our applications, just don't represent investment and these kinds of horizons, right? Is this thing a utility? Is it going to become a utility? Should we be buying it, or should we be moving more aggressively to a service that's provided?
The make versus buy decision is something where this is incredibly powerful. And the thing about a map, and what Simon keeps repeating this over and over again, Simon Wardley, it shows position and movement. And if you draw an arrow on the graph on a graph and it doesn't make any difference what direction the arrow points in, you haven't got a map. A map has a position you're starting with and where you're trying to get to. That's really the important aspect of it. We're trying to understand where we're trying to go and what's blocking us from getting there and all those kinds of things. And and the other thing is all maps are wrong, some maps are useful. If you keep those two phrases in your head, then you're, because I'm certain that people will look at that map, Kubernetes guru, say, you got it wrong and you've missed out a bunch of stuff. Yeah, I know. Yeah. But there's more, but from an executive level or a management level point of view, this is the major things we need to understand and we need to make decisions on. And you can go do the details, and yes, there's a lot more stuff in there. But from a, we are migrating to the cloud, what does that mean point of view, then it makes sense.
Yeah, and for me, in terms of the customer engagements I've been doing, it just addresses one of the key problems I've seen throughout the last couple of years of helping organizations shift to the products and value streams, which is that there tends to be a really clear understanding of the top left of the business application where most value needs to go. There tends to be some understanding of, okay, we'll get this from our cloud provider, we'll get this from another vendor, right? So the utilities. But what this makes explicit, and I think it'll be counterintuitive to a lot of people who start using it at first, is that all those investments that A, should be utilities but aren't, start showing up on the map, and B, the things that are actually specific to the business, right? Let's say back to the call center, actually creating some of the machine learning and data pipelines needed. Well, maybe you're not ready to outsource to a vendor or at this point, right? That is actually the business.
Like a fraud analysis model or something like that is very specific to the kinds of fraud you get on having a model that's listening for patterns of calling or whatever it is that are that thing you're looking for.
Yeah, exactly. And you want to leverage as much utility as you can and use Connect and but it actually makes explicit those investments, those product value streams that are not customer facing, but are critical to supporting key functions like fraud detection. So I think this is, again, a great tool for that kind of that product thinking that's at the investment level for the organization. And again, I think what is so key here is that, like you said, the map has arrows and things are shifting, right? And things have been shifting very quickly per a bunch of what you just, what you went through in your reInvent talk in terms of all these new services that you need to pick and choose to move to, which means sunsetting things that you've been building in-house. So, okay, awesome. So where do you want to go next? This, hardware.
I think this is getting a bit long. So let's just quickly talk about some of the hardware pieces and then what I'm currently focused on for 2021 myself, which is, so start with what is big data, right? We've heard the phrase big data. And the original idea of big data and why we all got Hadoop clusters was we were trying to do analytics jobs that didn't fit on one machine. And Hadoop was a way of using breaking the problem into a way that you could throw lots of machines at the problem, and you need to sort a petabyte of data or whatever it was. It used to be I need to sort a terabyte of data, right? And then we got machines with a terabyte of RAM, which is kind of where I'm going with this, right? At some point, the size of the one machine, you see, the amount of disk space you've got means that you can put it all in disk on one machine now. And the amount of RAM you've got means you can process it in memory on one machine. So what is the largest problem you can solve on a single machine, which means it's no longer big data? So the definition of big data is a moving target, is one way of thinking about it. And then there's this sort of hierarchy of what you can fit on disk on one machine versus what will fit in memory on one machine versus what will fit in the GPU memory on one machine. Because once you get something that fits in GPU memory, you can, and nowadays it's like 40 gigabytes for one GPU. And that's quite large, really. I remember when, I'm old, but I remember it's 1 gigabyte for an entire database on disk was big. But anyway, so now 40 gigabytes in memory on the GPU, and I'm trying to remember, I think it's 7,000 cores in one GPU. And it's a SIMD machine, so it's, but if you think about, okay, let's say I have 40 gigabytes of data there, and I want to do a full table scan of that data. Look for something in it. I have 7,000 cores doing that in parallel across my 40 gigabytes of data. The internal memory bandwidth is 1.2 terabytes per second, okay? This is ludicrous numbers. If you have any idea, like normal machines, memory bandwidth is about 30 to 40 gigabytes per second. Just to give you, that's how fast memory is on a normal machine. Inside a GPU, it's 1.2 terabytes per second.
The M1's got pretty good, gone a little better, but yeah.
But M1, so a Graviton is better. This is why, the ARM, the latest RAM, it's a whole other thing. But we could get into ARM chips, but the point is that there's this sort of, you hit this, as your problem shrinks, all of a sudden you get this ridiculous speed up becomes available to you. And then we have a cluster of 8 GPUs together, which gives you 320 gigabytes, and they're on a 600 gigabyte per second NVLink, which is higher latency than being inside one GPU, but the bandwidth is there. So you get to do algorithms, and these things are used for deep learning training, but that's not the only thing you can do with them. I think and then we announced this EC2 cluster system, which is 4,000 of these in a cluster, which is just, again, a ludicrous system. It's like, I forget, it's some number of petabytes of RAM. And I go, okay. I just love throwing these sort of ridiculously large hardware things around again. Like, hey, what problems can you solve that you couldn't plausibly solve a few years ago with this stuff?
So is there a graph database that doesn't fit into this then?
Well, this is one of the uses for these machines. Like the biggest memory machine we have right now is 24 terabytes. We use it for SAP HANA normally, but you can get several terabytes just as a regular instance size, and the latest GPU instance has over 1 terabyte of RAM in it. So terabytes are relatively easy to come by. Tens of terabytes are there if you really need them. And if you want to run a graph database that's non-partitionable, it's hard to partition graph databases. They're one of the use cases. So I then started looking at what could you do with this that you couldn't do before. And as well as things like SAP HANA graph databases, had this idea that you could deploy all of your containers inside the same machine so that the containers could talk to each other at memory speed. And right now, with the traffic from one container to another normally goes outside the instance and back in again because it goes to the switch. And the switch, containers assume that the other containers are not on the same machine as them. So data gets scattered, routed. So the question is, how quick could you be and how much traffic would you get rid of if you fast pathed that? And how much overhead could you take out? And it turns out most of the overhead of talking on the network is serialization and deserialization of data. And the reason you do that is because you're crossing a trust boundary, a failure boundary. And if you're in the same address space, you're not actually crossing a failure boundary. So you don't have to serialize and deserialize, so you can use a shared memory transport where you don't deserialize, you pass the raw data and you just update it in place. So all that SERDES goes away as well. So there's a few things here where, and then there's some other stuff you run into. So that I've got a whole series of layers of thinking here, this is much more of kind of a long-term research. But what it lets you do is think about taking a monolith, breaking it into individual pieces, which are independently deployable microservices, but they're running in the same address space. So you get back some of the efficiency of the monolith. Mm-hmm. Although you get the agility deployment of a microservices model. Anyway, I came up with a name for this. I call it Petalith, the Petalith architecture. So, I don't know. And I've been sort of bouncing the idea around a bit, but I don't think anyone's ever gone to build this yet. So this is definitely something that I think sounds plausible, but there's a lot of bits needed to do this. And I'm kind of floating the idea in my talk and in this podcast, because if anyone's working on this, let me know, because I think this is interesting stuff. And the software architectures we need to manage it are a little different. And then I highlighted some companies and research projects in the talk. So Dan Bittman has an operating system called Twizzler, which is interesting. One of the other things that's happening, which hasn't really got here yet, is persistent memory, so main memory being persistent instead of volatile. And he's built an operating system for that. There's a database company out of the UK called Brightlight with Y's in it, BRYTLYT, which has a GPU that runs entirely in a database, Postgres compatible, runs entirely inside the GPU and can do these ridiculously fast lookups because it's running at GPU speed. And a few other things, a few other people I listed in there. So that's kind of that was the next bit. There's me trying to think about, and I don't think this is something people are going to do in 2021.
Right.
I think the research projects and the interesting startups are happening, and it's very fringe. I'm saying that this is in 4 or 5 years. This is something that could be mainstream, and I've sort of been at the beginning of things before. This smells to me like the beginning of a thing. So I think this is, I'm sort of doing a long-term prediction here that this is a place that could be interesting to play with.
Right, but Adrian, I guess this will probably track like your previous predictions, so it'll be ubiquitous in 10 years. But until then, it sounds like the actual trend of moving more and more compute into and storage into GPU and memory is just going to continue, right? Where there will be use cases that organizations and enterprises have for putting the entire GraphDB into memory, and services that are around right now for actually heading in this architectural direction, even though if this happens, this will completely change. It will change architecture for microservices.
So back in 2008, I did a keynote on how we should be using ARM chips in data centers. I did it at Usenix, I think. So I was about a decade ahead of where I needed to be. But I also went and I called them millicomputers, and I got all the domains, millicomputing, milli whatever. And of course, nobody ever used that term, but I was right in the end. It was like milliwatt level computing. Like
10 years of all those domain names, that must have added up.
This domain names don't cost that much. But I keep saying somebody wants to actually bring out millicomputer, make me an offer. I have all of the domains. So I also went off and said, I'm going to call this thing a petalith. So I grabbed all the domains for petalith that I could find. But somebody snuck in on the Twitter handle, so oh well. So I don't have that. But so I'm sure it will end up being called something different. But I don't really care what it's called. You got to put a stake in the sand or whatever it is, stake in the ground on it.
Oh yeah, I mean, this would be a whole new generation of. I mean, everything right now turns into electricity and cost. Right? Is all the network traffic, all of the storage. This would just fundamentally transform, I think, the compute profile for.
Yeah, and the problem, of course, is you have a failure domain if a machine dies.
Right.
Then, so you also need. Yeah. But we have 400 gigabits now. We have 4 100 gigabit links on the instances. Mm-hmm. So we have 400 gigabits of bandwidth to pump your data that you're changing to another instance in another zone. I put in a different.
That's across zones.
Well, it's out of the instance. Yeah. If I'm trying to replicate somewhere safe, I put the other instance in another zone.
Yeah.
Yeah, and all the data so you've got massive amounts of bandwidth to have all of those containers talking to lots of other containers somewhere else, or Lambda functions or whatever. Anyway, so that's kind of the other thing you have to. The reason why people don't want to put everything in one machine is because when it dies, it all goes away in one go. But if you get your chaos engineering right, you don't care. It's just like another chaos monkey problem. I just lost a zone, but I'm okay with losing a zone. The system still works, right? If I really can automatically fail over a zone loss, then losing one of these massive machines is just like a zone loss. It sort of all ties together in some way, but like I said, I'm kind of just spitballing ideas here and trying to. This is not in any way an AWS policy or architecture trend or anything. It's something that I've been talking about for more than 5 years, and I've been talking about this way before I joined AWS. So it's something that I think is likely to happen eventually. It's far enough out that most customers aren't thinking about it at this point. So given that AWS is a customer-driven organization, we have to get the customers thinking about it so that then they ask AWS to do it, and then we end up building it, right? So I'm trying to like, it's like, how do you do chicken and egg? Well, start off with a cardboard cutout chicken and wave it at people. I don't know how you bootstrap this process, right?
So yeah, exactly. And Adrian, I think this is just fascinating. So I will just transition myself from this blowing my mind to that other topic I want to make sure we get to, because all these petabytes sound like a lot of electricity.
But you wouldn't believe. So look at your application. How many cycles in your application is spent converting thing to strings and back again?
Yeah, that's a lot of electricity. Yeah.
It's a ridiculously high proportion of all compute cycles are being spent serializing and deserializing. Yeah. If you're doing XML, you're just wasting ridiculous amounts.
Can you imagine actually getting the carbon footprint of all the serialization?
Exactly. So I think that this is, if you could get a architecture where a lot of the serialization wasn't needed, but you still had all the other benefits of microservices, then you get back to the efficiency of the monolith. Just another, monoliths have their places and they're very efficient. They're just hard to modify quickly because they bundle too many things in, too many concerns in one place. You have to separate the concerns. So anyway, so that's kind of segueing into the final subject I had, which is around sustainability. And there were 2 announcements at reInvent I want to highlight. One is that Amazon, as of 2020, is the world's biggest buyer of renewable energy. And it was over 3 gigawatts of capacity is now in contract. Wow. Not all rolled out, obviously, but we have contracts and we've bought just an insane amount. The total amount we have, I forget the exact number, it's like 4.5 gigawatts, something like that. It's a huge amount of electricity capacity, and that's because we are moving we have a path to 2025 of having all of Amazon electricity, AWS and Amazon, being sourced green. Renewable. And the problem Amazon has is it's a logistics company. We do a huge amount of moving atoms around, whereas the other cloud providers are mostly moving electrons around. So Amazon as a company has a much bigger footprint than, say, Google or Microsoft. It's actually closer to Apple. Right? If you think Apple moves lots of hardware around, and Amazon's a logistics business, it has a similar kind of thing. Our footprint is big because we move so many things. So we're working on a very holistic view of solving that for all of Amazon, not just focusing on the AWS part of it. Werner also had a section in his keynote where he talked about renewable architecting for sustainability and how you build that into the way you think about your architecture. And the best proxy to optimize for is cost. If you save cost, you have lower AWS bill, then you're also saving carbon footprint because it's very, very closely related. And that's the best thing you can do. And things like not running cron jobs, that they're all on top of the hour, so you get a big load spike out of it. So trying to avoid load spikes unless you absolutely have to for business reasons is another.
Yeah, Adrian, can you just dive into this? Because I think that how profound the savings are from the economies of scale of cloud, and just how much of the planet's carbon footprint will move to workloads running in the cloud. I think just this cron example of the fact that if you centralize all of this into a centralized set of control planes, you can actually just dramatically reduce electricity usage. So just tell us quickly this cron job story, because I think it's the perfect thing people have in their minds.
So if you take a typical data center, there was a study in 2019, I think, which we published, which showed that this is the efficiency of a typical data center. We took the median data center, and then if you take that and compare it to the cloud, we run much higher utilization, and we run much more efficient, more modern hardware. And because of that, with 3.6 times more efficient, right, in terms of carbon footprint than a median data center. right, just going to cloud, and then taking into account, in addition, the renewable energy that we're sourcing compared to the renewable energy that a typical data center resource uses, we end up 88% saving in carbon footprint from just taking the same workload and running it in the data. Same Intel processor type, same workload, didn't do anything, you just moved it to cloud. That saves you 88% as of 2019, and we're continuing to improve that number as we roll out more renewable energy. So that's kind of the baseline. And then you look at, well, how do workloads drive the consumption in the cloud? And if you look at the average utilization of a system, that is not the carbon footprint. It's the peak, right? So, and it's not the peak utilization, it's the peak provisioned capacity. So think of how much capacity you had to provision. What is the peak usage of that? And then you dial back to the average utilization, right? And that peak provision capacity is driven by the sharpest and tallest load spike in your system. And if you can get rid of cron jobs that synchronize activity across lots of machines that all hit your network switches at the same time, or hit the AWS control plane at the same time, or fire all your Lambda functions at the same time, then you're actually reducing the amount of provision capacity that AWS needs to handle these spikes. And we manage this for you, and it's our job to minimize it. The more synchronized activity that people have, particularly around on the hour and on midnight load spikes, the better we can optimize. So there's just a little nice optimization that it doesn't really hurt you to be 1 minute after midnight or 1 minute before midnight, but you're actually reducing the carbon footprint of the overall capacity that we have to provide to service your Lambda functions, for example.
Yeah, I think that's fascinating, is that this kind of optimization of electricity and carbon can only be done at a global cloud scale. You should just try to see what happens in AWS. Just shift everyone's clocks by a few minutes and see how that.
And what we're doing, so internally, we're now working across all the service teams, sort of one by one, and sort of saying, okay, so how do we improve the carbon footprint of this service? Right? How do we make this into a goal across all of AWS and all of Amazon? It's already, there's a VP of sustainability for Amazon, Kara Hurst, who's been there 6 years. We have a climate pledge. There's a whole lot of work. There's a large team there working on sustainability. They're putting solar panels on the top of Amazon facilities, not AWS, the Amazon shipping facilities, all that kind of stuff, doing deals to buy electric vans, delivery vans. So there's a huge program going on at Amazon, and I'm basically working on the AWS component of how do we blend what we're doing into that. And that's kind of the final part of this talk, was just sort of saying one of the things I'm doing. We're still early days on a lot of this, but the project I'm involved in is a Linux Foundation project called Open Source Climate, which is to build a standard way for financial organizations that manage assets to look at the asset risk of climate impact on their portfolio. So that's what's driving it. And then the other side of this is that every public company is starting to deal with reporting their own climate footprint, at least quarterly, sort of an annual or quarterly basis, as part of your quarterly financial results. You put a carbon footprint in there. Amazon now has its own footprint report. You can go see what that is. It's done at the Amazon complete level, not at the AWS level. And a lot of our customers do as well. And it's starting to become mandated. So the European community has a mandate that people should do this. Other countries, one by one, are having this mandate. And it's one of the sort of election pledges of the Biden administration, is that they are going to have this mandate as well. So it's going to become, during 2021, this is going to become top of mind for a lot of public companies. Like, how do we report this? How do we do it in a standard way? What are the models? So OS Climate is standardizing those models as an open source project, data science models and data sets, so that you'll be able to do the basic modeling using the open source data set. And then we're going to build a more detailed sort of provider ecosystem marketplace on top of that for people to kind of build more specific stuff. But we're going to take the base level of reporting and make that an open source generic thing. So again, the Wardley map of this, so we're taking a bunch of proprietary, fragmented data reporting models, open sourcing it and moving it to kind of an as a service with this OS Climate Data Commons. So I'm basically leading, along with one of our Amazon sustainability leaders, Anna Pinheiro-Privet. She's been running the Amazon Sustainability Data Initiative for a few years, and I'm working with her on OS Climate, and we're building out AWS's response to, we're prototyping it for OS Climate, basically. So that's keeping me busy right now.
That's awesome. That's so great. I mean, this is, I think, a topic that a lot of us care so deeply about, which is how the technology landscape is changing the planet and how we do better for our kids. And just, again, your view on the fact that the way that we approach cloud scale architecture actually has a massive opportunity to do much better than what we're doing today. And that I guess the more you go serverless, the more green you are is the bottom line.
That does help. It does have you've got 100% utilization, and all of the time stuff you're not using, we can use for somebody else. So the optimizing for carbon footprint moves to an AWS responsibility, right? So that's another thing we're going to handle for you. So to some extent, just if you optimize for cost and use serverless, you're doing most of what's needed. Anyway, so that's kind of it. And then just looking at where we're going with this OS Climate stuff, I think the key thing here is we're leveraging the power of the financial system to drive public companies to invest in climate change mitigation, because they have to, because otherwise their future value of their stock will be marked down, right? So what we're doing, when you're doing an asset model, you're saying, in 4 years' time, this stock is going to be impacted by climate change. Yeah. And it's the economic impact, the market impact, and the direct impact, like your buildings are underwater, right? That's a direct impact. The market impact is your market goes away. If you're currently operating gas stations, we're going to move to electric cars. So that is a market shift. And then there's a customer sentiment, basically. That's the marketing shift. And then there's the economic impact. We're going to be spending more and more on climate mitigation, building seawalls or whatever. Are you making money out of building seawalls, or are you being impacted by the economy diverting more resources into climate mitigation? So there's less money to spend on whatever you have, right? So that all these things are driving, those three things go into the model, and you say, if you're not figuring out how to respond to this, then you're going to be marked down by the asset managers, and your stock will be worthless, and not worthless, but marked down over time. So it provides a big financial incentive for people to go fix this problem, which this is the best way of doing it, right?
And so just to wrap up, so people can check out OS-Climate now to start.
Yeah, os-climate.org is we haven't done the first release of the OSC Data Commons yet. We're working towards an alpha release sometime in the next few months. That will be a little data lake where you can see the basic models and see some of the data. And the first alpha will be pretty low functionality, but we're trying to gather all the data and the models together and bundle it into a GitHub account. GitHub/OS-C is where it will appear eventually.
Awesome. And I certainly hope that the world's large organizations are all using this well before that 10-year mark that we keep referring to.
Yes.
Excellent. Well, Adrian, thank you so much. I think our listeners will have many, many hours of materials to get through. Resources.
How many hours is this by now? I forgot.
I'm afraid to look. It's definitely the longest one. So, but no,
we cut a few bits out. Maybe cut it up a bit.
No, I think we need to keep it. Last time when we cut you off short, I got so many complaints that I'm not doing it again. We'll just
all right. Okay.
This special long.
All right. Well, thank you. This has been excellent, and thanks for the opportunity to go a bit deeper on my reInvent talk and just talk about all the things I think are going on that's cool right now.
Excellent. This has been so great, and let's revisit the 1 and 5 and 10 year mark, because I'm sure a lot of
I'll come back do this next year and see what I got right. See if I have any new ideas for 2022.
Exactly. Excellent. Thanks so much, Adrian.
Okay. Cheers, then. Take care.
A huge thank you to Adrian for joining me on this episode. For more, follow me and my journey on LinkedIn, Twitter, or using the hashtags Mik+1, the project, the product. You can find Adrian on Twitter and Medium by searching @AdrianCo. I have a new episode every 2 weeks, so hit subscribe to join us again. You can also search for Project to Product to get the book, and remember that all author proceeds go to supporting women and minorities in technology. Thanks, stay safe, and until next time.